Hello class, in this module we're going to be focusing on finding our delta H in a different way. You've just seen in the previous module that you can find delta H with the coffee cup calorimeter. Now we're going to use Hess's law. Now Hess's law, it's an indirect method to determine your delta H. Turn on my pen. It's an indirect method. What do we mean by an indirect method? Well, you're going to take the sums of the heats of a set of reactions, which are these. So we're going to end up summing these up. And then we are going to manipulate them to look like our desired reaction. So that's what we want to manipulate. We want to manipulate these set of reactions. So I'm going to label these reactions. So this will be reaction number 1. This will be reaction number 2. Now, if I want these two reactions to look like our net result, I've got to manipulate it a little bit. Now this one we don't have to do much, but I notice that we have C in this first reaction, but we don't have a C in our net. We have a C in the second, but not one in our net. So we can go ahead and cancel those out. They're the same moles. They match. So we can cancel those because they're on either side. And now if we take a look at this, our 1, we would just sum these up. We have A plus 2B in our reactants, and those are in our reactants. Then we have a 2D in our product, and that is in our product. Now, once you're done manipulating these reactions, you will simply just add up your delta H's. So here then, for the whole delta H of our reaction, we have our delta H1 and delta H2. So now let's apply that, since that's the idea, let's apply it to an example. So we have our Hess's law problem here, and we're going to look at the oxidation of sulfur to sulfur trioxide. And we're going to use the equations below to calculate our delta X. So this is what we're going for. This is our nets. And we need to manipulate equation 1 and equation 2 to look like that overall net. So what did we notice about this? So I'm going to go ahead and just take it step by step. Now I notice here we have sulfur in the reactants, and I have sulfur in the reactants here. I have SO3 in the products. I have SO3 in the products here. But I notice already that I've got 2 here, but I don't have 2 in my product. So with equation 2, what we're going to do is we're going to manipulate that to get rid of that 2. So we're going to leave 1 as it is, and we're going to start with equation 2. So with equation 2, to get rid of that 2, I'm going to multiply everything by a half. So I have a half times our 2SO2 plus our O2 going to SO3, 2SO3. So multiply everything by a half. So let's go ahead and multiply through. So this will leave us with SO2 plus half of an O2, and then now just 1 SO3, 1 mole of SO3. Now whatever you do to the equation, we have to do to our delta H. So we multiplied everything by a half, so I am going to multiply my delta H2 by a half. Now let's go ahead and rewrite number 1. So number 1 is our sulfur plus our oxygen, and that's going to go to SO2. So let's go ahead and see if we are ready to sum these up yet. So this is our new number 2, so I'm going to kind of separate these to keep it a little bit more clear. So if I sum these two reactions up, let's see if it would look like what we want. So again, we want sulfur plus 3 halves O2 going to SO3. So here, my reaction 1, I have sulfur in my reactant, so that looks good. And if I look at my oxygens, I have a half here, and if I know this is just 1, but I can make that 2 halves. So 2 halves and a half is 3 halves, so that's good for my oxygen. And here I have an SO3. So the only thing I have to do here is cross these out. This delta H1, we didn't change anything for 1, so I'll leave it as the same. Now if we sum those, it does equal our sulfur here, plus 3 halves of oxygen, and our SO3. So we've manipulated them. Now we just work on the delta H's. So our delta H of our reaction is going to be our half times our delta H for our second reaction plus our delta H1. So if we go ahead and plug the values in from above, we get a half times our delta H2, which is minus 198 96.4 kilojoules, plus our delta H1, which is minus 296.8 kilojoules. So when we add these together, we're going to get minus 396 kilojoules. And there's our answer. Okay, so there's an example of Hess's law. We're going to do one more example because it's going to be a little bit more manipulation. So in this module, we'll just do one more. So here we're given 3 chemical reactions. And so I'm going to go ahead and just label these now. So 1, 2, and 3. And then we have to figure out how to manipulate these to get our delta H for this overall reaction. So where should I begin? So let's take a look at what we need to do first. Well, I notice that there's no right away. So here, let's do our reactants and products. Here's SO2 here, and here's an SO2 there. So I know with equation 1, I am going to not really look at that so far because the SO2 is in the place and O2 is on the reactant side. And it has a sulfur in there, and our overall doesn't have a sulfur. So that must mean this sulfur has to cancel with another sulfur later on. But for right now, I'm not going to focus on number 1 because the product is in the right place in one of the reactants. Now, if I look at reaction 2, I have a hydrogen and an oxygen. So again, an oxygen is in the right place, and it has a water that's in the right place. It's in the product side. So it's in the product side in 2 and the product side in 2. So right now, I'm not gonna manipulate that either. I'm gonna go for the one where I'm gonna notice a change first. So if I look at 3, I have hydrogen, which is not in my overall, and I have a sulfur, but I have H2S here. Now H2S, it's on the product side, and it needs to be on the reactant side. So what I'm gonna do is I am going to flip equation 3 around. So I'm going to manipulate that. And that's what I wanted to show you. That's a bit different. That's new from the last 2 examples. So if I flip this around, I'll have H2S, and that's going to go to hydrogen plus sulfur. And because I flipped that around, now the delta H, I have to make it negative. So whatever my delta H is, I have to make it negative now. So if you flip the equation, you make it negative. Now let's go back. I'm going to go ahead and rewrite number 1 to kind of see where we are. So there's sulfur and oxygen, and that's going to form SO2. And right now, let me not forget to put my 3 there. Then right now, I'm going to just say delta H1. And let's see if I need to do anything to equation 1. Well, equation 1, I know that I want 1 sulfur. Okay, so here, well, I don't know if I need 1 sulfur, but I know I have 1 sulfur, sorry, and then there's no sulfur in this reaction. And let's look at the oxygen. So the oxygen, I know in the end I need 3 of them, but by just looking at this, I can't tell. But SO2, I need 2 of them. So, okay, that gives me some information. In the end, I need 2 SO2s. Equation 2 doesn't have an SO2, so I'm going to multiply this whole thing by 2. So I have 2 here now, then I'll have 2 oxygens, and then I'll have 2 SO2s. Okay, because I want, again, this SO2 here to match the SO2 in my products for my desired reaction. Okay, now let's take a look at number 2, reaction 2, to see if there's anything I need to do there. So number 2, I have hydrogen, I have half of an oxygen, and I have water. Now let's look at our overall equation. So what I notice already is I've got 2 waters. So I'm going to use a different color. So I have 2 waters here. So what do you guys think I need to do here now? So I'm going to have to make this 2, right? To make that 2, I have to multiply everything by 2 again. So that means I'm going to be multiplying my 2 by my delta H2. So if I multiply this by 2 and this by 2, so if I multiply this by 2, I end up getting just 1 oxygen, and I have my 2 hydrogens, 2 waters. Okay, so everything is multiplied by 2. So then let's go and add these up. We don't know if we're done yet, but this is how we're going to check. Well, here, I know that right away, I see that I've got 2 H2 and only 1 H2. So already, what do we have to do? I've got to now multiply that whole thing by 2, equation 3. So I'm going to multiply the H2S by 2, this H2 by 2, and the sulfur by 2. So let's see if it can cross out now. So how do I know that I want H2 to cross out? H2 is not in our net reaction, so I know I need to get rid of it. So I'm going to cross this out with this, so that's legal. And I have 2 sulfur, so I can cross those out, that's legal. And anything else I need to cross out? Well, I need to keep the 2H2S. I need to keep the oxygens, and if I have 2 here plus 1 here, that's 3. And then over here, 2SO2 plus 2 water, we're done. So now I can go ahead and just write it out. I've got 2H2S, just to double check, plus I've got 2O2 plus 1O2, which is 3. So let me rewrite that. So that's going to be 3O2, 2 plus 1, and that looks like 30. Okay, I'm rewriting that, so which is going to be 3O2. And then I've got 2SO2 plus 2 water. Now I'm looking at my reaction again, and that matches the reaction above. So what's the last thing we're going to do? We're going to sum up our delta H for our reaction. So here we're going to have minus 2 times our delta H3. And then we're going to go ahead and add our 2 times delta H1 plus 2 times our delta H2. So now we can just plug everything in. So we get equals minus 2 times, and delta H is a minus 20.6 kilojoules, plus 2 times our delta H1, which our delta H1 is minus 296.8, plus our 2 times delta H2, which is minus 285.8. Okay, 285.8. So now let me just double check those values. So delta H1 is minus 296.8, delta H2 is minus 285.8. Now if I add all of these up, I'm going to get minus 1124. And then notice I don't write the units the whole entire time just to save myself some time. Minus 1,124 kilojoules is going to be our answer. Okay, so there's Hess's law.